Hey guys, Eddie the Magic Monk here doing another video for calculus, and today the topic is optimization using derivatives. So if you're watching this video, I'm guessing that you have had quite a lot of experiences with dealing with differentiation in calculus, and you have probably seen a lot of my videos on calculus already. Otherwise, you will find this problem a little bit difficult. So optimization, what does optimization mean? It means the process of finding the largest or smallest value of some quantity. So in this situation, the quantity that we need to find is the area of the rectangle inscribed in a semicircle of radius 2 units. Okay, so we want to find the largest possible area of this rectangle, and once we find that, we can then say what are the dimensions, i.e. the length and the width of the rectangle. So let's firstly draw the situation with a diagram. So if we draw a semicircle, so let's just draw a circle and then cut it in half. So this is our circle. So if we have a circle, let's say this is the center point of the circle. Let's say it's about here, and we cut it in half. Okay, we cut this circle in half, so the bottom half is gone. Now the radius of the circle is 2 units, so from here to here is 2 units, and we want to inscribe a rectangle in this semicircle. So let's just draw a rectangle in here using another colored pen. So let's draw this little rectangle in the circle. Remember, a rectangle has to have 90 degrees in all 4 corners, right? So that's a rectangle, and we want to find the largest possible area of this rectangle. So the rectangle might not be this one, okay? It could be, for example, another possibility could be it could look something like this. Okay, we don't know what the rectangle with the largest possible area would look like. So basically what we're looking for is the length and the width of the rectangle. Okay, we want to find out the length of the rectangle and the width of the rectangle of the largest with the largest possible area. So how do we do that? Well, if you guys can see that the question has specified a condition or a constraint, and that is the radius of the circle has to be 2 units. So using that constraint, we know that from the center point to the corner of the rectangle is going to be 2 units, because that is the radius of the circle. Now if I label the sides of the rectangle, okay, if I label this side as side A, okay, the length from here to here is side A. Okay, and I call this side here, which is half the length of the rectangle, side B. Then I can say that A squared plus B squared equals 2 squared using the Pythagoras theorem. Okay, using the Pythagoras theorem, we know that this side, and this side is a right angle triangle, so a squared plus b squared equals c squared. So a squared plus b squared equals 2 squared. So using this, we can find a relationship between a and b, or we could say that b squared is equal to 2 squared, which is 4, so I'm just going to say 4, minus a squared. So I have now expressed b, or actually one more step, so b is equal to the square root of 4 minus a squared. So I have now expressed b in terms of a. Okay, so how does this help us? Well, now we can say the area of the rectangle is equal to the length times the width. Right, area of a rectangle is length times width, and the length of the rectangle is 2 times b. Right, because b is half the length of the rectangle, so 2 times b is the whole length of the rectangle. Okay, so its length is 2b, w is the width, which is a, so it's 2ba, or 2ab, whichever way you want to write it, it's all the same. So now that we know the area of the rectangle in terms of a and b, we can substitute our expression for b in terms of a from the Pythagoras theorem, okay, from the right angle triangle, into where b is in the area formula. And the reason we want to do that is because we can only differentiate an equation when there is only one variable. Right now there are 2 variables, but as soon as I substitute this expression into where b is, the only variable left is a, and then we can differentiate it. So the area is going to be 2a times, instead of b, I'm going to write square root of 4 minus a squared. Okay, so now I have an expression for a with just one variable. So actually, let's start another, recipe for doing all optimization problems. And the first step of doing any optimization problem is that you need to write an expression for the quantity to be optimized, and in this case that is the area that we are trying to optimize, right? Because it says find the largest possible area. So we need to write an expression for the quantity to be optimized in terms of one variable. So we need to say a equals something, and we're only allowed to use one variable in here. And in this case, the variable is the variable we have used is a. Right, only one variable. So once we have done that, we can differentiate the quantity. So step 2, okay, so these are the steps right now. Step 2 is to differentiate the function or the expression with respect to that variable. Okay, so we now have to differentiate this expression. Okay, we now have to differentiate a with respect to little a. right? Little a is actually the width of the rectangle, and big A is the area. So don't get confused about that. So now I'm going to say A dash is, what is A dash? Well, before we do that, you might have noticed that A is made up of two expressions multiplying by each other, right? So you can call this part here F and this part here G. So A is really F times G, where F is 2A and G is square root of 4 minus A squared, right? And because we're going to differentiate it soon, it's probably better if we write that as 4 minus A squared to the power of a half, because square rooting an expression is the same as raising it to the power of a half. So F is equal to 2A, G is equal to that. Now let's differentiate it. So F dash is 2 and G dash is half times 4 minus A squared to the power of negative a half times negative 2A, using the chain rule for differentiating the outside and then multiplying by the derivative of the inside. So simplifying that part, G dash is then equal to so negative 2 and 2, I guess you can cross that out, right, because 2 divided by 2 is 1. So it's negative A times by 4 minus A squared to the power of negative a half. So you can simplify that as negative A over 4 minus A squared to the power of a half, which is square root. Okay, so that is what G dash is. So we now gonna substitute F dash, G, and G dash into this formula here, where A dash is equal to F times G dash plus G times F dash. That is called the product rule, in case you have forgotten. That's what you use for differentiation. I can see the excitement on your face. So F is equal to 2A and G dash is equal to negative A over the square root of 4 minus A squared, plus G is 4 minus A squared to the power of a half, so that's square root, times F dash, which is 2. Okay, so it's F times G dash plus G times F dash. Okay, so now I guess the next part we can work on is the next step. So the next step to our steps for doing optimization problems. Okay, the next step, so step 3 is find the value of let's just call our variable, let's just call that x. Find the value of x when y dash is equal to 0. Right? Because that's where the maximum / minimum occurs. Right? The maximum and minimum of a function occurs when the derivative is equal to 0. If you don't know what I'm talking about, please go back to some more calculus tutorials. So we're now going to substitute 0 where a dash is, because a dash is the derivative. So 0 equals, 2a times negative a, so that's 2a squared negative over square root of 4 minus a squared plus 2 times 4 minus a squared. So now, because we have 0 here, I'm going to move this to the left hand side. So that will be 2a squared over square root of 4 minus a squared equals 2 times square root of 4 minus a squared. Okay, and now what we're going to do is we're going to try and solve for a. So let's multiply what is on the bottom of the left hand side, multiply it on the other side. So 2a squared is equal to 2 times square root of 4 minus a squared times square root of 4 minus a squared would just be 4 minus a squared. Right, because if you guys remember, square root of x times square root of x equals x. So that's why the square root sign has disappeared. Okay, and now if we divide it by 2 on both sides, the 2 will now disappear. So a squared is 4 minus a squared plus a squared on both sides. So then we have 2a squared equals 4 divided by 2 on both sides. So a squared equals 2 and a is equal to the square root of 2. So we have now found the maximum a. Okay, but to prove that it's the maximum, we then need to do another step. Okay, so to show that it's a maximum, we need to do step 4. And that is determine whether it's a maximum or minimum using the second derivative test. Second derivative test. So now we need to go back and we need to find so we've already got a dash. Let me just copy that. So we've already got a dash. We've already got a dash, which is that. Okay, and what we want to do is we now need to find a double dash. How exciting. A double dash equals. That's the second derivative. The second derivative. And basically we need to differentiate all this again. So we need to differentiate this. We need to differentiate this. And find out what a double dash is. And I'm just going to do it instead of talking through it because it'll take too long. But basically what you have to do is you have to treat this as f and this as g, differentiate it, so you have f times g dash plus g times f dash, and then you need to do this part here, so you can just differentiate that and that will give you all that give you, so you got 4 minus a squared to the power of a half times 2. So moving the half to the front, so that will cancel that out, and then that will be negative a half times negative 2a, and then you're gonna do this f times g dash and all that, and you should end up with you should end up with 4x times x squared minus 6 over 4 minus x squared to the power of 3 over 2. Okay, sorry, not x, a. So now what you're going to do is you're going to substitute in a is equal to square root of 2 and see what a double dash is. If a double dash, right, the second derivative, if a double dash is equal to a number bigger than 0, so if a double dash is bigger than 0, then it's a minimum. If a double dash is smaller than 0, then it's a maximum. Okay, so let's test it out. So let's put all this in the calculator. So a double dash is equal to 4 times square root of 2 times square root of 2 squared minus 6 square root of 2 squared, so that will cancel that out. So over 4 minus a squared, so again that'll just be 4 minus 2 times, sorry, to the power of 3 over 2. So let's put that in your calculator, and the answer is -8, which means a is a maximum. Right, as I stated here, a double dash is smaller than 0. In this case, -8 is smaller than 0. Therefore, a maximum occurs at point A. Okay, at x is equal to A. So now what I'm going to do is find out the area. So I have the square, the rectangle, alright, and I have a is equal to square root of 2, so now I can find out what b is. So b is equal to the square root of 4 minus a squared. So let's copy that down. Oops, I'm just going to write it. B is equal to 4 minus a squared square root. Alright, so B is equal to square root of 4 minus A is square root of 2, so square root of 2 squared is just 2, so that's B is equal to square root of 2 as well. So then I have the area is 2 times A times B. This area is equal to 2 times 2 is 4. Okay, so that is my solution to this question. Thanks for watching. Hope you learned something out of this. See you next time.